Welcome to the next video in the General Chemistry Fundamentals series presented by MCAT Genie. This video is going to be about stoichiometry. So in the last video, we discussed balanced chemical equations and balanced reactions, which are very important when it comes to determining stoichiometry and doing calculations related to it. So what is stoichiometry? It's a weird sounding word to the normal English speaker. So stoich comes from the ancient Greek root of stoichion, which means element or constituent, something that creates something else. And metron is the root for metro or metri, which means that we have a measurement. So essentially what we are is we're dealing with the measurement of elements, which makes sense because we're dealing with balanced chemical equations. But what are we measuring exactly? So the key is we need to know the mole ratio of the reactants to each other, as well as the reactants to the products and the products to each other from a balanced, and this is the key, balanced chemical reaction. And you can't determine anything stoichiometrically until it's balanced. And we'll discuss why. So the main thing is that when we are doing stoichiometric calculations, the goal and the utility of this, which you should always keep the use of each of these concepts in mind. What is the use? Is that it allows us to determine the amount of reactant that's needed to do a reaction, how much reactant do you need of each kind, if there are multiple, and how much product do you expect to form theoretically. You'll probably remember from your general chemistry and organic chemistry labs that we don't always create the theoretical yield, or we pretty much never do, because there's a difference between the real yield and theoretical yield. But for today, don't worry about the real yield. We'll talk hypothetically speaking if we live in a perfect world. So let me give you a quick analogy. In terms of pizza, again, because it's so easy to relate pizza to chemistry, imagine I tell you to make a balanced tasting pizza where the sauce, the dough, and the cheese are all in the right proportion. Then we need 1 pound of dough, we need 1 pound of sauce, and we need 1 pound of cheese. Proportionally speaking, it's 1 to 1 to 1. Those are our reactants, our ingredients. But if you went and you checked and you saw that there's only 0.75 or 3/4 of a pound of dough, but there's 1 pound of cheese and 1 pound of sauce, then you know very intuitively that either you're going to make a pizza that's too small because you don't have enough dough and it's going to have extra sauce and cheese on it, but that wouldn't be balanced. So a balanced pizza with the limit that you have on your dough is going to lead you to only be able to make 3/4 of a pizza as we normally would have. You would use 0.75 pounds of each, and then you would have 0.25 pounds excess of the other two, which would be the cheese and the sauce. So if that example makes sense, then why don't we try this out in the context of a general chemistry reaction, which, who knows, you could see on the MCAT. So we'll try to approach this discrete question here. And the question is, how many grams of water are produced when 16 grams of methane combust in excess oxygen? So it's very important to know that they're telling us directly that the 16 grams of methane is the amount of methane, the mass of methane that we're starting with, and there's an excess of oxygen. So by default, that means that our methane has to be the limiting reactant. So everything is going to be limited by that. So it doesn't really matter how much oxygen there is because it's in excess. So if we go back to solving the equation here, or the calculation, the main thing we first have to look at is the reaction balanced. So we look. And if you take a look, I already put the balanced equation, so you don't really have to worry about this, but you look and you check, is this the same number of carbons on both sides? Same number of hydrogens, yes, there's 4. Same number of oxygens, so there's 2 from the carbon dioxide and 2 from the water. So everything is balanced, so we're good to go. Now that we've done our little checklist, we can start working on the problem. So the first question is, what is the mole ratio between methane and water? Since methane is the limiting reactant and water is the product we're hoping to form, then theoretically speaking, the mole ratio is 1 to 2. But how many moles is 16 grams of methane anyways? So the first conversion you're going to have to do will be going from grams to moles of methane. And how do we plan on doing this? Well, if you watched my mole conversions and mole calculations video, then you would know that we need the molar mass of methane. And so the question is, what is the molar mass of methane? Well, if you look at methane, we know from the periodic table that carbon is about 12 grams per mole, and hydrogen is about 1 gram per mole. And we have 4 hydrogens, so that gives us 4 grams per mole. Just bear with me here. And so if we add that up, that means that methane should be 16 grams per mole. I gave you an easy number to deal with. So very easy to tell that if you have 16 grams of methane and you have methane, which is 16 grams per mole, then intuitively speaking, you know, the grams will cancel out, moles will go to the top, and we have 1 mole of methane. So back to what we had said before, we know for each 1 mole of methane, we can expect to get 2 moles of H2O as given by our balanced reaction. And therefore, I don't really have to do much more than just multiplying the moles of CH4 by 2 because it's a 1-to-2 ratio. Every 1 mole of methane that we put in is going to create, theoretically speaking, 2 moles of H2O as a product, as well as 1 mole of carbon dioxide as a product. Let's not forget that. It's just not what the question asked for, and the oxygen was in excess, so we don't really have to pay attention to that. So our final answer will be 2 moles of H2O. Why don't we move on to a slightly more difficult example? So in this case, the question is, if 5 moles of hydrogen gas react with 2 moles of oxygen gas, how many moles of water form? So just keep in mind, the MCAT does not typically ask these types of questions in a discrete way, but it will be implicit within a passage. So for example, if you see hydrogen gas written as a word, you have to know, if you need to write out this reaction, that it's H2 because hydrogen is naturally diatomic. And the same thing for oxygen, which is O2. So what do we have to check? Remember, the first rule is you have to check to see if it's balanced. Needs to be a balanced reaction. Can't stress that enough. So we look here, there's 4 H's on the left side and 4 H's on the right side, so that's perfect. We also have 2 oxygens on the left side and 2 oxygens here because the coefficient means there are 2 water molecules, so there are 2 oxygens. Very well. So we're balanced. We've done our check. We are good to go. So now to answer the question, well, we have to first answer what is the limiting reactant because that limits the amount of product we can form. So which one is in excess and which one is the limiting reactant, also known as limiting reagent? Well, we're given 5 moles of hydrogen gas. That reacts with 2 moles of oxygen gas. So our normal mole ratio as given by the reaction is 2 to 1. And there's an imaginary 1 next to the oxygen right there. So I expect to have 2 times as much hydrogen gas as I do oxygen. And the question already gave me moles, so I don't have to convert from mass or anything. And so naturally speaking, I need to know which one is limiting. The easy answer is that the limiting reactant has to be the oxygen gas. And it's not because 2 is smaller than 5. It's because I expect there to be a 1-to-2 ratio between the oxygen and the hydrogen gas. So if there are 2 moles of oxygen gas, then I need at least 4 moles of hydrogen gas if that's the case, if I'm starting with 2 moles of oxygen. If I'm given 5 moles of hydrogen gas, clearly I have more than I needed. So therefore, there's 1 mole of hydrogen gas in excess. It's quite simple when you understand the concept, but in practice, when the numbers are not so nice like this and the ideas are more implicit and you're under time duress, it might not be so easy. So we practice like this. So in this case, I know that the oxygen is the limiting reactant, and we have 2 moles of this. And I don't care about the 5 moles of hydrogen gas because it's excess. So everything's going to be based off of this number 2. Keep that in mind. And because the ratio of oxygen to water is 1 to 2, then similar to the last time, we're going to multiply by 2, and we know that that's going to give us 4 moles of water. And it's easy as that. Hopefully everything we went over in this video makes sense. We will do more applied practice of this using MCAT related materials, so don't you worry, just keep an eye out for those videos. Thank you for watching and hopefully see you soon.